Alright, so what we're going to do today is going to make hot ice from baking soda and vinegar right here. I will be trying to do this experiment with red wine vinegar to make it more interesting, so we have some red ice. Now, this experiment will demonstrate 3 topics. First, supercooling. Something we haven't covered yet in class, but I think that's really interesting. Exothermic reactions, which we have covered in class, and which means that this ice will be generating heat. The heat will be going out. The thing will be going out of the reaction. Finally, crystallization. So you'll see that the ice will form crystals when it hardens. So what this calls for is a liter of red wine vinegar, and so I looked it up, and liter to cups, which is the measurement tool I'm going to be using right now, there are 4 1/4 cups in a liter. So I'm going to be using that to approximate what I'm going to do. I think, yeah, I've got a 1/4 around here somewhere. So we're going to be using that to demonstrate. First, alright, so now is the time where we're going to add baking soda slowly to the vinegar. Now the instructions of this little experiment tell me not to add it too fast. It's going to bubble up and you'll have a little volcano here. So essentially what this is going to do is it's going to take the baking soda and the vinegar, and it's going to make carbon dioxide gas and sodium acetate. If you look down below, Editing John will add in the formula for you, and so you can see what that looks like chemically. So without further ado, I'm going to begin to add 4 tablespoons, or in this case, 8 half tablespoons of baking soda. And so as you may hear, it bubbled up pretty nice. I'm going to let you have a look at that. See that? That's for one little thing of baking soda. So now what we're going to do is we're going to boil this concentration until we start to see a crystal skin or film form over it. So, difficult to let you see here. We're going to let you have a gander. So you can see it's boiling there, and if you trust me, I'm going to keep boiling that to get the crystal film there, and then I'm going to cut over and show you that, alright? So here you can see, as you can see, it's frozen. Now the outer metal side of the bowl is very cold to the touch. But, as you see, if I touch, I break the seal, the thing is hot, almost burning to the touch. Alright, so it's a little bit of work, excavation. We are left this piece of work here. Looks almost like ice. Bit red color. It's because I used red wine vinegar instead of normal vinegar. But you can't see it, but as I can see, it's warm to the touch. Now I tried to get a temperature on this. Didn't work. In the future, I would have some better materials to work with that. But yeah, it is warm. And now I'm going to try to do some different things by adding water back to it and reheating it. And we'll see if we can get it to crystallize a bit. Alright, so I wasn't able to show you some of the other things that I wanted, because it just simply wouldn't work. But just based off the hot ice you're able to see, there are 3 clear topics that were demonstrated. First, supercooling, which is the process of where you chill a liquid below its freezing point, but it doesn't turn into a solid. It becomes a solid once it is in the presence of what's called a seed crystal. So what I did, I took some of the stuff that crystallized on the edge of the pot when I was boiling it, and I put it in there, and it immediately hardened. Another element that was shown through this experiment was exothermic reactions, which are chemical reactions where heat is released as part of it, and it's the opposite of an endothermic reactant. So while the reaction is going on, the excess energy is released. And the final one is crystallization, which is when a solid forms like crystal structures I'm sure you've seen before. And we see this in the ice, certainly, and I don't think there's much we need to go into here, but it's another cool aspect of science as well. And crystals themselves are very interesting and intriguing for scientific purposes. Alright, thanks for watching. I hope you enjoyed this, and I'm sorry that I wasn't able to get the whole thing exactly right. Thank you.